Hey everybody, trigonometry day number 1. Topics for the day: unit circle, sine, cosine, tangent, and some translations. Okay, so let's look at a couple of sample problems to kind of warm us back up to trig. Recall that the inputs of a trig function are angles, and the outputs of trig functions are ratios. Not rados, but ratios. Okay, so x in number 1 will be a ratio, and x in number 2 will be an angle. Therefore, let's go ahead and look at what would the sine of pi over 3 be. Now, a couple of triangles you can look at. One being in the unit circle would give us a 1/2 and a root 3 over 2. Since this would be our angle, pi over 3, the sine would be root 3 over 2. Okay, of course, here's our angle. Opposite over hypotenuse would give us sine. All right, another unit circle, well, non-unit circle friendly, but special right triangle ratio here. I like 2, and I like a root 3, and I like a 1. So I've just scaled that triangle by a factor of 2, but I still get opposite over adjacent, root 3 over 2. Okay, cosine is equal to -1 over root 2. Most of the time when you see a root 2, it's going to involve a pi over 4 or some scale of pi over 4. Now the cosine is negative in both the second quadrant and the third quadrant. So I know I'll have answers here in quadrant 2 and here in quadrant 3. So in quadrant 2, I would anticipate an angle of 45 there and an angle of 45 there in quadrant 3. So the first angle that I would get would be this angle, which is pi minus pi over 4, which is 3 pi over 4. So one of my answers would be 3 pi over 4. Could also write that as 135 degrees. Another answer that I would get, let's see here, would be pi plus pi over 4, which would give me 5 pi over 4, or what would that be? 180 plus 45, 225. I can't do maths right now. Okay, so there we go. A couple warm-up problems. Let's go ahead and get into the definition of sine, cosine, and tangent. All right, so the definition of x and y on a circle. Okay, so here's the unit circle. If I've got a point here, let's call it P, and I know I'm on the unit circle, right, because the radius of the circle is 1, therefore this point would be 1, 0. This point would be 0, 1, etc. So the point P would be the point xy. All right, now, if I want the cosine of theta, let's call this acute angle theta. The cosine of theta would be the adjacent side over the hypotenuse. So adjacent over hypotenuse. Therefore, this is why in the unit circle we define the cosine as x. In the same manner, we would define the sine as y, which is opposite over hypotenuse. And then unique to this is tangent. Tangent would be opposite over adjacent, which would be y over x, which could also be written as sine over cosine. Okay, so some basic definition there of trig. Let's go ahead and use them here on the next slide. Okay, the unit circle. This is our friend. Okay, so let's go around the circle here. We'll call this 0 degrees, or we could call it 360. I'm going to call it 360 just to kind of keep it from being too basic. Okay, then we've got our 30, 45, 60. This will be 90. Then we add 30, 120, 135, 150, 180. Continuing on, we're going to add 30 more to 180. That's 210, 225. This will be 240, 270. We're going to go around the next time around the circle, and we'll go radian measures. This will be 300. This is 315. This is 330, and then we get back here to 360. So in radians, I'll do those in red. This would be 0 pi or 2 pi. This is pi over 3. This is pi over 4. This is pi over, oops, I'm sorry, that should be pi over 6, pi over 3, pi over 2. Okay, now we get into some fractions. I'm sure you love fractions. I'm going to do the pi over 4s first. So here's 1 pi over 4. This will be 2 pi over 4. This will be 3 pi over 4 and 4 pi over 4. So I would have 3 pi over 4, and of course 4 pi over 4 would be that. Then I'd have 5 pi over 4, 6 pi over 4, which would be 3 pi over 2, and 7 pi over 4. Of course, I come back here to 2 pi. All right, let's do some pi over 6s. This is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So 4 pi over 6 converts to 2 pi over 3. 5 pi over 6 stays the same. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3. And 11 pi over 6. Okay, so we got all our angle measures in both degrees and radians. Now let's fill in the first quadrant and then subsequently use patterns in order to do the rest. So this is the point 1, 0. This is the point 0, 1, negative 1, 0, and 0, negative 1. Okay, using special right triangles, we could fill in this pi over 6 here, which would be root 3 over 2 and 1/2. And proportionally speaking, or symmetrically speaking, excuse me, this would be 1/2 square root 3 over 2. And then two different forms you could use here, either 1 over root 2, 1 over root 2, or you could use square root of 2 over 2, comma, square root of 2 over 2. Now, the remaining points on the circle are going to be filled in using symmetry, and symmetry only. So I'm going to fill those in on the side and then review them. Okay guys, filled in the rest of the unit circle. Take a look at these 3 points and see how they relate to these 3. Of course, the sines and cosines are the same other than the sign change, right? So in quadrant 2, the cosine is negative, the sine is positive. In quadrant 3, negative, negative. And in quadrant 4, positive, negative. This should become your friend. It should be something that we don't have to think about too much. It just comes to mind. So there's the unit circle. Let's use it to do a few translations. Okay, let's do a few translations on sine, cosine, and tangent. So first thing I'm going to do is I'm going to draw an acute angle. I'm going to call it theta, and I'm going to put it in quadrant 1. Okay, so this would be the cosine of theta, comma, the sine of theta. And I can do that just for the only reason because we're on the unit circle. So we know the hypotenuse is 1. Okay, so I'm going to lay this out a little bit using the sine function. I'm gonna just put points up here, and then we're gonna fill these in. So here I have the sine of theta. I'm gonna put it in red. There's the sine of theta. Here is the cosine of theta in blue, and of course this is a right triangle. So if I were to graph sine of negative theta, okay, sine of negative theta would put our angle down here. Okay, that is the same. Okay, you'll see what I'm getting at here. Cosine of theta has not changed, but our output for sine, right, because this angle right here is negative theta, is now the opposite. Therefore, sine of negative theta is equal to negative sine of theta. Okay, so sine of theta plus pi. Well, the sine of theta plus pi would be down here. Right, I've added pi units to theta. Therefore, again, we would get negative sine of theta. Okay, sine of theta minus pi. Okay, sine of theta minus pi would be in the exact same place. Taking theta, and now I'm subtracting pi. No change there. That'll be negative sine of theta. Sine of pi minus theta. Okay, so pi minus theta, if I were to sketch that, would be this angle pi minus theta radians, which would again give us the same sine value. Therefore, this would be a positive sine. So graphically, let's look at this. How about 2 pi minus theta? Let me sketch that to the side here. All right, here is the angle 2 pi. If I subtract theta away from it, this would be the angle 2 pi minus theta. And of course, that would be the opposite sign of what it was. Right, so the sine values would be opposite in sine. I know that's kind of goofy. Okay, how about sine of pi over 2 minus theta? Okay, so this one, with this one, what I'm going to do is I'm actually going to use a triangle. Okay, so let's say that this is theta, and the sine of theta is sine, right? So then this angle right here would be pi over 2 minus theta. So the sine of pi over 2 minus theta is actually equal to opposite over hypotenuse cosine of theta. Okay, so in the same way, I'm going to go to the cosine column here. The cosine of pi over 2 minus theta is going to be the sine of theta. We can sketch this out real quick and just kind of toggle around the circle. Here is theta, and of course we've got, as we did before, sine theta, cosine theta. So here, cosine theta is positive. All right, and I don't really care about sine theta. So let's put some points up here. Where would the opposite of theta be? Right, the opposite of theta would be here. This is negative theta. So has anything changed with the cosine? Nope. That's why cosine is an even function. How about cosine of theta plus pi? Here's cosine of theta plus pi. Has cosine changed? Yes, it has. It's now negative. Right? You can see that it's the opposite. So negative cosine theta. All right, how about cosine of theta minus pi? Likewise, it's going to end up in this same spot right here. Therefore, that would be negative cosine theta. Okay, cosine of pi minus theta. All right, that would put us right here where this is theta. And that will be the opposite of cosine theta. All right, and then cosine of 2 pi minus theta. All right, just like we did before, here's 2 pi. If we subtract theta, of course, cosine will still be positive. So we're going to get a positive cosine. Very, very similar to the sine, except for these two values here. Okay, tangent. Tangent is sine over cosine. Okay, and just so you know, tangent is positive in quadrants 1 and 3 and negative in quadrants 2 and 4. Okay, so the tangent of pi over 2 minus theta is actually equal to the cotangent of theta. All right. Let's look here. Tangent of negative theta. Well, that would put us, of course, the tangent where we started here would be positive. Negative theta would put us here. Therefore, we would have a negative tan theta. Okay, tangent of theta plus pi would put us down here in quadrant 3. That'll be also positive tan theta. Tan theta minus pi will put us again in that third quadrant. And tan theta, pi minus theta. So tan pi minus theta would put us in quadrant 2, which would be a negative tan theta, or just the opposite sign of what it originally was. And then 2 pi minus would put us in quadrant 4 again, which would make it an opposite of tan theta. Now, this might be confusing. There's a lot going on. Geometrically, it's like, what is he talking about? These identities are good to know when it comes up, but you can also just use expansion identities, right? So we'll get to those in a little while about in a few lessons, like cosine A plus B. If you're confused, just expand it using those rules. Okay, I got a few examples, and then you'll have some time for some homework today. Okay, so given tangent of theta is 4/3. Let's sketch that. Okay, so let's put it in, and I really should specify here. Let's say quadrant 1. Okay, tangent is 4/3. Here's theta. I could use Pythagorean theorem, which would allow me to find the hypotenuse is 5. So find the sine of theta and the cosine of theta. Okay, I've used Pythagorean theorem, a little right triangle trig here, and sine would be 4/5, and cosine would be 3/5. Cool. Let's simplify in number 2, cosine of pi minus theta minus cosine of theta. So that requires us to recall this. Okay, so the cosine of pi minus theta, let's sketch it. Let's say theta is here in quadrant 1. If I took pi minus theta, that would put it here in quadrant 2. So what's the difference between those two cosine values? Well, originally it was positive and now it's negative. Therefore, this is equivalent to negative cosine theta minus cosine theta. So we can simplify this to be negative 2 cosine theta. Okay, so we've used one of those identities. Let's use another one here in a second. So sine of negative theta and cosine of pi over 2 minus theta. Well, sine of negative theta was negative sine theta. And cosine of pi over 2 minus theta was the same as sine theta. So simplifying, I get negative sine squared theta. There you have it, guys. That's day 1 on Trig. We got some quality problems that you can be working on. Let me know if you got any questions. Otherwise, I'll see you in the next video.